Good morning, good afternoon, good evening. Whenever you're watching this video, I hope you're doing well. So far this week, we've covered volumes of prisms, then we moved to volumes of cylinders, and now, just like with the surface area that we've covered, we're moving to volumes of pyramids, okay? Now, I hope you got a chance to look at the other video that I posted there that showed the proof, basically, of why the formula is what it is. If you didn't get a chance to look at that, go back and take a look at that. Normally I would want to do that in class, but since you're not able to be in class today, or at least without my guidance here, it makes it a little difficult. So I thought that video made a nice representation of what we would have done. Now, looking at 10.6a with the volumes of pyramids, I'm going to bring up the formula here. We'll write this out. Remember, the formula is 1/3 the base area times the height of the pyramid. Okay? So just keep that in mind. The base area, always opposite the vertex. We've talked about that already. And the height we are talking about is perpendicular to the base, not the slant height. The slant height is over here. Remember that. Slant height is there. We don't want that. We want the actual height, okay? So again, the height. Okay? So with that being said, we would like to figure out the volume of these next couple of pyramids. Now, in the first pyramid that I show you, this one right here, I don't know if you remember the term from the other day when we got the chance to talk about this, but this is an oblique pyramid. The vertex is not directly over the center of the base. So as a result, it's not a right pyramid. Again, that would be something up in here going down to the base structure. It's been moved over, okay? So how do we calculate this volume? Well, the volume being 1/3 the base area times the height, I'm going to go ahead and plug in the base area, which is going to be 8 square centimeters. Notice it says square centimeters, so I don't have to do anything else to it. The base area is already being given to me. And the height is, again, the shortest distance from the vertex to where the base would lie. Okay? And so on the line of the base, that would be this distance here, and that is 18. This is our height. Okay? Now, you could go ahead and plug this in your calculator, but I just want to show you something that can really make things easy for you. I always try to find if 1/3, if a factor of 3 goes into either one of these numbers, I can simplify this up pretty easily. So does 3 go into 18 evenly? No, not at all. Does 3 go into 8 evenly? No. Does 3 go into 18 evenly? It does. It goes in 6 times. So I can reduce that down to 6 by dividing 18 by 3. And then from there, 6 times 8 is 48. And the volume of this figure is going to be 48 cubic centimeters. Okay? All right, so very basic, basically just plug in and simplify. Now, the problems do get a little more complicated. As you look at the next structure here, you'll notice that this is our slant height. So you may want to make a note of that, the slant height. We don't want the slant height, we want the actual height. So, in order to do this, they've done a nice job of shading in your base. So I can actually write this down, 1/3 the base area times the height. And we can say that 1/3 times the base area, which would be 32 times 32. That would be the area of the base. And then whatever the height's going to be. Now, in order to figure out what the height's going to be, I'm going to draw a line like this. Okay? And see if we can figure out what this length is going to be. Now, it's very important that you can visualize this next part. So I'm going to do this for just a quick visual here. When I went back to, let's see if I can go back to the, right there. Let me see if I can align that, okay? What we're given in this problem down here is that this slant height's given, and we have the height. And what I tried to do was form a right triangle. So basically, you might want to jot this down. Your height being perpendicular to that length right there, this is your height, and this is your slant height. And so the slant height will always be the hypotenuse to the height of the figure, okay? So just keep that in mind as we work out this next part here. So looking at the next section, let's see if I can get us back in alignment here. There we go, okay? I'm going to put the right angle over here. Now you may be thinking to yourself, but Mr. Couples, there's already a right angle. Well, that right angle is not within the triangle that we're looking at. You got to look at this from two different dimensions. This dimension goes back into the figure. This dimension rides right along the lateral face. So this right angle is referring to the base edge, the slant height, and the lateral edge here, okay? So with that being given, this length right here, hopefully you're thinking in your mind already, is going to be half the base edge length. So I'm going to put down 16. And then I'm going to come over here and I'm just going to redraw that structure so we can see it a little bit better. We have 16, we have the height of the figure, and we have the slant height, which is 34. So we can go ahead and do the Pythagorean theorem here. 16 squared plus h squared equals 34 squared. Okay? Now from there, if you go ahead and work things out, we know 16 squared is 256. I know 34 squared is greater than 900, so 1296 is what I've written down. And then subtract those two, okay? You get 1040, and then the square root of 1040 will be the length of the height. Now, I don't have to go any further than that if we're going to round to the nearest tenth place. If it was simplest radical form, you'd want to go ahead and simplify that up. And so from there, I go ahead and plug that in for my height. And then to the nearest tenth place, make sure you've calculated this out correctly. You're going to get a volume of 11,007.7 cubic inches. Okay. All right, so that's not a very big structure if you think of the base being 32 by 32. You know, well, it's a little less than 3 feet by 3 feet. And what's the height there? Nearest tenth place, that height, let's see here, the square root of 1040 is about 32 inches in itself, you know, a little like almost 32 and a quarter inches. And so we're talking about something that would have come up to about your waist, okay? And so, yeah, that's the volume. All right, let's move to the back side. And the type of questioning differs a little bit from here on out in the fact that now I'm going to give you the volume and I'd like you to figure out a dimension within the figure. All right, so here's what I want you to see. This base down here, this right angle is referring to the base. So if I was to redraw this base over here, the base of this triangular pyramid looks something like this. Okay, so just keep that in mind. And the height is given right here. Height. All right. So if I were to plug this in, volume equals 1/3 the base area times the height. Your base area is actually going to be the area of this triangle right here. 1/2 base times height times the height. Now, it should be understood that this is the height of your base. Height of base. And this is the height of your pyramid. Okay? And so I'm going to put a little H1, H2. Okay? Now, how do you figure out the rest of this? Well, if the volume is 126 cubic units, and I plug in 1/3 parentheses 1/2, the base of my triangle here is x. So I plug that in. The height of my triangle is 9. And the height of my pyramid, as we've already identified over here, is 14. Okay? Now the question then becomes, can you simplify that up? Now, I gave you some hints on how to simplify things up on our very first problem when I said, does 3 go into any of the numbers, you know, and then you go ahead and multiply those two together first. Taking a look up here, does 3 go into 14? No, it does not. Does 3 go into 9? It does. So I'm going to multiply 9 by 1/3, and 1/3 of 9 is 3. Or I'm going to divide 9 by 3 and get 3. Does half go into 3 evenly? No. Does half go into 14 evenly? It does. I should say this. Does 2 go into 14 evenly? It does 7 times. Okay? So in the end, you have 126 cubic units is equal to 21x. 7 times 3 is 21x. And then I would just divide by 21, and you get 6 as that length, the base edge length that you're looking at. Okay? All right, so hopefully that made sense. Again, that's all algebra, so don't complain because that's geometry. That's all algebra right there. Question is, can you do the algebra? So hopefully you're able to do that. The very last problem I want to look at is a little bit different. What we have here is a pentagonal pyramid. All right, 5-sided base. We want to figure out the volume of this pentagonal pyramid. So I'm going to do 1/3 base area times height. Okay. Now the base area of these regular polygons can be a little more difficult than the basic square, rectangle, or even triangular structures. And so what I'm going to do, and you may want to show this on your paper there, if I find the area of this triangle right here, and then I multiply that by 5, I'm going to have the total area within that structure. Okay? So the first thing I'm going to do is take 360 divided by 5, and we get 72 degrees there. Now I'm going to drop this down perpendicular here and show that this length is going to be 5 meters. Well, half of 72 is 36, so this angle measurement there is 36 degrees. From there, we can use our tangent function to find the apothem length right here. And I can set it up like this. The tangent of 36, the degree, is equal to the opposite over the adjacent, 5 over a. If I go ahead and solve for the apothem right here, you're going to have cross-multiplying a times the tangent of 36 equals 5, and then dividing through by the tangent of 36, you get the apothem length to be 5 divided by the tangent of 36. Okay? So hopefully you were able to do that faster than me. I couldn't write it down very fast, but yeah, that's what it's going to be. So the base area, being a triangle times number of triangles, the area of the triangle would be 1/2. The base of our triangle is 10 times the height, 5 over the tangent of 36. Now that's the area of the triangle, okay, just this portion right here, times the number of triangles, which is going to be 5. Okay, so that's the base area, the area of that whole pentagon, times the height of the pyramid. Now the height of the pyramid, you can kind of see it right here, but it's going from the base all the way up to the vertex, which is going to be 15 meters there. Okay. All right, so if you want to go ahead and work that out, you could probably simplify some of that down. I'm not going to worry about that right now. I want to see if you can plug that into your calculator. So if you do that, what you should end up getting is 160.2 meters cubed. Okay, cubic meters. And that's what I'm looking for there. So I hope that was all understandable. I hope you learned something there, and that you can apply it on the homework tonight. So go ahead and take a moment and see if you can do those problems for me on the homework, and then check with the sub and see how you did. All right, thanks for listening. Good night.